The crew leaves port on a mission to hunt giant bluefin tuna, reaching nearly 3 meters and over 400 kilograms.
Only a 150-meter industrial platform can safely deploy longlines powerful enough to withstand giant bluefin tuna.
To find giant bluefin tuna, they track temperature breaks and offshore fronts where baitfish and giants converge along deep contours.
Giant bluefin tuna concentrate along narrow bands where warm and cold water masses collide in powerful, food-rich boundaries.
Years of longline data reveal repeat corridors where giant tuna over 3 meters regularly migrate.
Every component is built to handle explosive runs from giant bluefin tuna, weighing half a metric ton.
Industrial longline systems let crews present hundreds of baits along routes patrolled by giant bluefin tuna. Each branch line becomes a potential contact point with a single giant bluefin tuna racing through the water column. High-energy baitfish are chosen specifically to attract giant bluefin tuna, accustomed to chasing fast-moving prey. Each hook must be baited and clipped with precision when targeting giant bluefin tuna capable of straightening inferior hardware.
Thousands of meters of line will soon suspend bait at depths where giant bluefin tuna cruise between temperature layers.
Robust terminal gear is essential when targeting giant bluefin tuna capable.
We check every single connection before it hits the water.
Each segment of longline is armed in sequence, transforming bare monofilament into a lethal grid for giant bluefin tuna. Soon each bait will disappear into offshore water, where giant bluefin tuna patrol in scattered schools. Setting speed is carefully regulated so baits for giant bluefin tuna deploy cleanly without tangles.
Each clipped branch line becomes a drifting target for a single powerful giant bluefin tuna strike.
Floats mark the longline's path, allowing the 150-meter vessel to track where giant bluefin tuna may encounter baited hooks.
The longline settles across depth layers where giant bluefin tuna switch between warm and cool water masses.
Here, only apex predators like giant bluefin tuna and their prey cross the silent grid of steel and monofilament. Exact placement ensures baits remain in the strike zone where giant bluefin tuna are most active. With the set complete, a continuous corridor of opportunity now hangs waiting for giant bluefin tuna offshore. Scent and flash spread through the water column, drawing giant bluefin tuna from surrounding currents. The crew monitors scattering layers and bait signatures that often precede giant bluefin tuna arrival. Somewhere below, giant bluefin tuna cruise silently through darkness, potentially crossing the baited mainline.
A fleeting shadow hints that at least one giant bluefin tuna has entered the perimeter of the longline set.
Deep scattering layers shift, suggesting giant bluefin tuna are beginning to move along the set. First pulses indicate contact as powerful giant bluefin tuna brush against baited branches. Lightning-fast silhouettes reveal giant bluefin tuna circling cautiously just beyond full visibility. Sudden acceleration signals a large giant bluefin tuna charging the line at full velocity.
Heavy load surges through the system as the first giant tuna commits to the hooked bait.
High-speed torque forces the monofilament into extreme stress near the first branch line.
Surface disturbance shows the giant tuna executing rapid lateral runs beneath the swell.
A hooked giant bluefin tuna can generate instant acceleration capable of testing steel swivels.
Hydraulic strain rises fast as the giant attempts to outrun the industrial longline system. Bi-angle pulls reveal the tuna diving deeper, forcing the crew to stabilize equipment. Deep dives allow giant bluefin tuna to regain momentum and strain the monofilament to its limits. Drag fluctuations mark the moment the giant tuna begins its first circular high-speed run.
Circular runs force the entire longline segment into continuous rotation and high tension.
The system warns that a giant bluefin tuna over 500 kilograms is applying maximum force.
Surface signatures confirm rapid, erratic movement directly beneath the longline corridor. High-speed directional shifts produce sudden torque spikes across multiple branch lines. Maintaining alignment prevents catastrophic snapback from the giant tuna's resistance. Vertical bursts add unpredictable strain as the giant tests every point of connection.
Surface breaches indicate extreme fatigue and rising vulnerability during the fight.
Rising heat across the brake plates reflects the bluefin's violent acceleration during the early fight.
Temporary lulls often precede another explosive counterattack from a hooked giant bluefin.
Vessel maneuvering stabilizes the system, while the giant tuna prepares its next burst.
Maximum acceleration marks the climax of the early fight as the giant tests every remaining option.
Stabilizing pressure indicates the giant bluefin tuna is entering the controlled haul phase. Decreasing velocity shows the giant transitioning from attack to defensive retreat. Full retrieval begins as the exhausted giant bluefin tuna starts rising through the water column.
These final bursts carry enough force to stress industrial monofilament near critical thresholds.
High-energy tail bursts from a hooked giant bluefin tuna can displace even heavy surface hardware without warning.
Rotational maneuvers compound torque, challenging the crew's ability to maintain stable lift. Sustained load indicates the giant bluefin tuna is fighting with its remaining full-body torque.
Short downward bursts mark survival instinct as the giant seeks deeper refuge.
Retraction angles shift rapidly as the giant bluefin tuna fights the upward pull.
Lateral strikes generate heavy drag spikes during the ascent sequence. Extreme mechanical stress confirms the raw power of a hooked giant bluefin tuna during late-stage resistance. Bubbling flow shows the giant tuna nearing mid-water transition, where upward lift increases sharply. Spiral patterns complicate retrieval as rotational drag multiplies across the mainline.
Sudden tension spikes mean the giant still has power reserves despite prolonged struggle.
Reduced propulsion signifies that the giant bluefin tuna is nearing its physiological limit.
Stabilized load confirms that the giant tuna is transitioning into controlled ascent.
Approaching surface light often triggers brief agitation as the giant senses environmental change.
Even near exhaustion, a giant T bluefin tuna can deliver explosive upward runs.
Diminished roll speed shows the giant relinquishing its final defensive burst.
Deck preparation intensifies as the giant bluefin tuna nears surface intercept range.
Full aerial breaches occur when the giant summons its last explosive power against rising surface tension.
Surface resistance reveals the giant's remaining raw strength despite near-total fatigue.
Controlled restraint is essential to prevent dangerous lateral movement from the giant tuna.
Decreased propulsion shows the giant T bluefin tuna is nearly ready for final capture.
Once lifted into shallow surface range, the giant's mobility drops sharply.
Final resistance fades completely as the giant bluefin tuna enters the vessel's capture zone.
Heavy-duty landing gear prevents structural damage while hauling a giant bluefin tuna of this scale aboard.
Controlled elevation keeps the specimen stable while minimizing subtle load shifts.
Even post-battle, reflexive movement from a giant tuna can disrupt deck operations.
Proper stabilization ensures safe handling and prevents accidental roll during processing. Efficient workflow allows rapid continuation toward the next giant bluefin tuna on the set.
Additional contacts indicate multiple Giant bluefin tuna navigating the corridor simultaneously. At depth, explosive impact from a giant tuna generates shock waves that travel through the Longline corridor with tremendous force.
Heavy mechanical strain confirms that this tuna matches the size and strength of the earlier giant. Downward accelerations generate torque strong enough to test Longline connectors repeatedly.
Full-body aerial escape attempts from a giant tuna generate extreme strain across the industrial Longline system.
Each burst of propulsion from a giant bluefin delivers sudden drag spikes that challenge the stability of the industrial Longline system.
Rising friction reveals the heavy strain produced by the bluefin's unpredictable mid-fight counterattacks.
Broadside strikes often create the heaviest momentary load during retrieval.
Team coordination helps control the rising turbulence caused by the giant tuna.
Reduced turbulence suggests the giant bluefin tuna is approaching fatigue threshold.
Midwater ascent typically marks the last defensive stage for a giant tuna.
Surface breach indicates the giant's power is nearly depleted after extended resistance.
Ropes stabilize the specimen, while hydraulic lifts prepare for final hoisting. Industrial lifting mechanisms ensure reliable control of a multi-hundred-kilogram specimen.
Proper placement and restraint keep the multi-hundred-kilogram bluefin stable while the crew continues Longline retrieval operations. Accurate tagging ensures each giant bluefin tuna is tracked through the entire cold chain.
Precise navigation aligns the ship for retrieval of remaining hooks and potential giant tuna. Movement patterns suggest more giant bluefin tuna cruising the strike zone nearby.
Completion of the hull confirms the end of all giant bluefin tuna interactions for this deployment cycle. With 2 giants landed, the crew transitions to cold chain protocols aboard the 150-meter vessel. Immediate transfer maintains freshness of each giant bluefin tuna landed during the expedition.
Rapid cooling prevents structural breakdown in large, giant bluefin tuna muscle tissue.
Industrial-grade storage systems support multi-hundred-kilogram specimens with stable temperature control.
Consistent cold chain handling preserves quality for market-grade giant bluefin tuna. Sealed storage completes the first stage of processing before the vessel head toward port. Return transit allows the crew to prepare documentation for each giant bluefin tuna captured offshore. Major seafood hubs handle high-volume arrivals of deep-sea species like giant bluefin tuna. Stable berthing ensures safe offload of frozen giant bluefin tuna from the refrigerated hold.
Industrial cranes streamline unloading of multi-hundred-kilogram giant bluefin tuna for rapid evaluation.
Inspectors assess color, fat quality, and core temperature for premium giant bluefin tuna classification.
High marbling yields premium pricing for giant bluefin tuna in competitive seafood auctions. Demand from global markets drives intense bidding for top-tier giant bluefin tuna specimens.
Rapid post-auction movement protects the quality of each high-value giant bluefin tuna. Industrial plants follow strict protocols to handle giant bluefin tuna with maximum yield. Controlled cuts reveal deep red muscle characteristic of giant bluefin tuna harvested offshore. Packaging systems ensure each giant bluefin tuna portion meets export standards.
High-grade giant bluefin tuna is prized worldwide for exceptional texture and rich umami profiles.
Culinary presentation highlights the premium quality achieved through careful offshore handling. Fine dining venues rely on consistent high-grade supply from industrial longline operations.
Each voyage deepens understanding of giant bluefin tuna behavior and the industrial effort required to harvest them responsibly.